Hey guys, I thought I'd drop a little bit of knowledge on flight stabilization. I'm getting really big into FPV. FPV is a big growing trend, and especially here in Chicago, we have a lot of nasty weather and high wind that is, okay for an experienced line of sight model pilot, but for somebody like me who's just stepping into FPV from a completely different perspective, it really helps to have a little bit of help piloting the plane, and also something to keep the camera steady. So the two big competitors we have right now are the Eagletree Guardian and from Eagletree Systems, and the Orange RX 3-axis flight stabilizer version 2 from Hobby King. Now these both have some great features. First of all, let's start off with the price so you guys know what we're talking about here. The 3-axis gyro here from Hobby King is, I think it's about 17 to 20 bucks. So it's relatively cheap. The Eagletree Guardian is 62. Now there's a very good reason for that, and I'll get to that in 1 second. The first thing that you'll notice about these two is this one comes with leads, and this one requires that you get male-to-male servo extensions. So if you don't have male-to-male servo extensions or can't source them, this would be a good choice. The second thing is the sensing systems that these use. Now, and this is a very important distinction. The Orange RX, which is this guy, uses gyroscopes only. The Eagletree Guardian uses gyroscopes and accelerometers. Now let me show you the difference in how those two types of position sensors can sense an aircraft's position and why you might prefer one over the other. Okay, so gyros versus accelerometers. Let's pretend my little Sukhoi here is your aircraft. You're looking straight down the tail. Gyros can only sense rotation. For example, they can sense rotation along the roll, the pitch, the yaw axis. That's it. So if the plane is being pushed on by wind, it'll tend to roll or pitch, and the gyroscope will correct by sensing that, pushing the control surfaces in the opposite direction, and correcting the flight path. Now, accelerometers work quite a bit differently. So accelerometers essentially measure acceleration. So they do not measure the tilt of the aircraft along any axis, but they do measure how the aircraft is accelerating. So if I took the Sukhoi and I moved it, a gyro would not sense that because it did not have any change along any of the axes. It simply accelerated and moved to a different position. Now, the issue with this is that there are seldom instances in the real world where a plane will only do this, or for that matter this, or this. Very few instances in which that will happen. But when coupled with gyros, the plane is now able to sense if it's rolling, how fast it's rolling, and if it is accelerating in any particular direction. So systems like the Eagletree Guardian combine gyroscopes and accelerometers to give the aircraft much more accurate stabilization, which means that there is a much more locked-in feel of the aircraft. It means that the pilot's controls are not muted as much, because the gyros, essentially when they are plugged into your plane, the gyros get 30% of the control authority and the pilot gets 70%. Which is a problem. If you need to get out of a tough situation, you have to switch the gyro off and then correct, which for a lot of pilots who are not used to flying with gyros is a pretty tall order. An accelerometer can tell if the plane is being tilted, how fast it's being tilted, and if the pilot is giving input, it is capable of determining whether the acceleration that it is experiencing, for example, like a banked turn, is capable of telling whether the acceleration that it is experiencing is intended by the pilot or not. So it can switch back and forth and it won't limit your control ability at all. The other thing that makes these accelerometer-based stabilization systems preferential to a simple gyro system is the fact that this accelerometer and gyro hybrid system is capable of remembering how much acceleration was put on the plane to cause an effect. So let's say you're flying downward. The instant you let go of the sticks, it will raise the elevator, which will bring the plane back up to 0 downward acceleration, and as soon as it reaches 0, it's going to bring the elevator back straight and level the flight. So if you get into any trouble, you let go of the stick and it will fly it back to level for you. And that's awesome. The other thing is, it makes planes practically unstallable. The thing about that is, and the very cool feature of this, which still gives me a chuckle to this day, is this sensor sits in a big plane. It'll sit right about here. Now I've got this backwards. It actually goes, the lead side goes toward the tail. But what it'll do is, let's say you turn off the throttle and you hit full up elevator. What's going to happen is the plane is going to begin to stall, it's going to lose airspeed, and then it's going to start ever so slightly shifting forward before it stalls and falls. During that shift forward, the accelerometers are going to notice that the plane is beginning to accelerate downward, and before the plane can even begin to go half a degree out of its off the horizon, it will slowly reduce elevator input until the acceleration is back to 0. So literally, you cut the motor, you pull full up, and your plane just slowly kind of settles itself to the ground. I'm never going to use the word uncrashable, but for unstable aircraft like ducted fans or very fast flying wings, or any plane that is inherently tail heavy or has some sort of balance issue, this would definitely be a way of keeping your aircraft safe. Now, a gyro really can't do that. All a gyro can really do is remember where you told it to keep the plane stable. So right now the gyro is set at 0. Any wind that would rock the wings, or pitch it up and down, or kick yaw out of the way, kick the tail back and forth, would fight that wind to return the rotation to 0. Now, let's say you put some aileron input in, you rolled 90 degrees to the right. Now this becomes 0. So any wind that's blowing on the plane, or any instability, any turbulence, is going to be fought against until the plane stays in this position. And in fact, it'll stay like this even if you let go of the stick. It'll hold itself in a knife edge like this. Usually the high quality gyros will, but it won't really stabilize itself for you. It might move like this, it might move like this, if you get a gust of wind that does that, and it won't be able to correct for that because it's not able to sense that this or this is occurring. And it also isn't capable of fixing your mistakes because it isn't capable of sensing how fast you made them and how quickly the plane is entering them. Therefore, it can't tell how hard to make the plane correct to get out of it. So just to go over the features of these stabilizers, the Orange RX 3-axis flight stabilizer version 2 it's a decent stabilizer. You've got left and right ailerons input, elevator, rudder, auxiliary, which I believe turns stabilization on and off. You have an option to activate V-tail and delta wing mixers on the stabilizer itself, which is pretty cool. Your pitch and roll and yaw gains are controlled by the 3 potentiometers up top. And it's a very simple system. For what it is, it's fantastically cheap. It's about 20 bucks, which is much cheaper than Spectrum's AS3X system, which with an included Spectrum receiver, you can't buy it separately. So if you fly LRS 433, old school 72, if you fly Futaba, if you fly FreeSky, whatever, you're screwed. This is compatible with basically every radio type that sends PPM control. Now the Eagletree Guardian I like a lot because it has both the gyros and the accelerometers. It's significantly more advanced. You can switch between 2D and 3D, which is automatic correction when you let go of the stick or not. It is programmable by USB. There's a little USB connector. You can save planes in here, save profiles for different planes on your computer, swap it into another plane, literally click a button and download all your gain settings instantly, so you don't have to screw around with the potentiometers at all. The other thing that's really great about it is that it has constantly upgradable firmware. If they increase the sensitivity or the sampling rate, you'll get it immediately for free as soon as you download the firmware. And last but not least, I am a big fan of this guy because you can control the gain from your transmitter. And that's very, very important because these stabilizers basically act as a kind of like an autopilot. They take a little bit of control authority away from you, ever so slightly with this one, more significantly with this guy, to use that as, you know, the final boundaries for steering the aircraft under their own guidance. This one has a gain input. So let's say you put this on a knob on your radio. If it's getting too glitchy, just turn that knob down and it'll smooth your aircraft out, turn your gain down. It'll make it a little less stable, but if you're already a competent flyer, you can bring it back home without one of these. These are just a little bit of icing on top, a little bit of extra safety and stabilization, especially if you're taking some video from on board. So this one's awesome if you get into any trouble, if you have an emergency, if it's fighting you too much, you can either adjust your gains or you can switch it all the way off. This one is an on or off deal, no remote gain adjust. Alright guys, so I'm doing my best not to be a, total ridiculous Eagletree fanboy, but I just wanted to show you the software that comes for the Eagletree Guardian absolutely free. You connect it with a little USB connector, and you can see here, as I move the Guardian around in my hands, there's an artificial horizon. So you can see if any of your reversing is bad or whatever. You have your servo reversing options that are right here. You have your yaw, roll, and pitch potentiometers positions shown. So if you adjust the pots manually, and I'm going to do that right now, you'll notice that they will start climbing on the you'll notice that they'll start climbing on the display. So that's really awesome, because I have before on multiple occasions I've literally forgotten where I left the potentiometer, and that could be disastrous, like if you've left the gain all the way up or whatever. You can save them for another aircraft. You can use fixed wing, Elevon, or V-tail, just like the Orange RX. So if you fly a wing, like this one's going to go in my TBS Capriña, a build video of which will be available soon, I can load up the defaults, and then if I want to fly an EDF, slap this in an EDF with a little bit of adhesive tape, load the settings from that with a USB cable on my laptop at the field, and off I go. 2D settings, which are really cool. You've got heading hold, which is keeping the nose straight wherever you left it. Automatic turn coordination. Turn coordination is basically mixing your rudder in with your ailerons. And this will do it automatically if necessary, but if you're flying a plane like a wing that does not have a rudder, this is basically meaningless, so that can be left at 0. Stabilization, roll, and pitch angles, basically, let's see, it even tells us the target angle in degrees for when the control stick is deflected to its maximum extent at normal controller rates. Use 30 to 40 degrees for a beginner pilot, use 60 plus for improved maneuverability. Basically what that does is it limits the output. So if you've got a beginner pilot who's got what I like to call Xbox disease and is banging the sticks back and forth on the controller, you can move this down to keep the plane from getting completely thrown around the sky by a newbie. And center stick only stabilization mode, stay away from that. It basically, as soon as you move your stick away from the center position, it turns the stabilization off, which almost defeats the purpose of this thing. So here's 3D mode. There for advanced pilots. Basically read the instructions to understand what happens with these. Basically these are rates. They're measured in hertz. How many times does it sample and correct per second on pitch, roll, and yaw? And as I experiment with this, I'll tell you guys a little bit more about what this does. It's measuring angular velocity in rotations per second. So it direct rate speed for roll without getting into too much technobabble. If I crank the stick all the way to one side to roll it, it will roll 1 revolution per second. Hertz is always a measure of cycles per second. And when we're talking about roll, we're talking about a 360-degree roll. Servo configuration basically lets you center your servos from a laptop, which is awesome. And servo pulse frequency, that's really not something that we're going to have to deal with on an aircraft this simple. When I start throwing it into more complicated machines, I will show you guys how that works.